In this segment, we're going to illustrate the genus Vibrio, which includes Vibrio cholerae and also includes the lower yield bacteria Vibrio parahemolyticus and vulnificus. The name of this drawing is Colonel Cholera's Base Camp. It takes place in a military camp in rural Southeast Asia. So let's start drawing the setting. The reason we chose Southeast Asia is because cholera is endemic to developing countries. And over here is the colonel. He kind of looks like a dictator, but he's not quite that cool yet. He's just a colonel. And right off the bat, the colonel signifies something about Vibrio that we have to know. The genus Vibrio is a comma-shaped bacteria. Helicobacter and Campylobacter have a very similar shape, but they're slightly more helical or spiral. So comma-shaped is a buzzword specifically for Vibrio. And to represent this, we gave our dictator a very sexy comma-shaped mustache. For the most part in this video, we'll be talking about the species Vibrio cholerae, which causes cholera. And if you remember, that's the disease that kept killing off your family in the computer game Oregon Trail. But cholera causes profuse watery diarrhea. And I mean profuse, sometimes even 10 to 20 liters a day. And the stool itself is sometimes described as having the consistency of rice water. So this is easy for us to remember because the entire background of the scene are rice paddies with water on the fields. And to solidify that it's causing only watery diarrhea as opposed to bloody, we'll draw this outhouse over here. And you can see it's kind of overhanging the river. And in the river below, right here, you can see that the water is sort of brown. And so this really literally signifies watery diarrhea. And this is also very literal in its illustration of how cholera is transmitted. If you could just imagine that this soldier up here in the bathroom has cholera and he's having diarrhea into the river, then downstream from the river, the poor farmer that drinks the water is going to also get cholera. So in other words, cholera is transmitted fecal-orally via poor sanitation that leads to contamination of food and water sources with human feces. Now over in the front, we'll draw another soldier, and he's holding a map of the entire area. Notice we made the river on the map especially windy. We did this because we want the river to represent intestines. So now look back at the river and pretend that the river banks represent the mucosa of the intestinal wall, and the river itself is the intestinal lumen. And with this model, we'll describe the pathogenesis of cholera. Now in the river, or the lumen, we'll draw a raft. This raft is going to represent one Vibrio bacterium, or one bacterial particle. We'll make it comma-shaped and red, the red of course because Vibrio is gram-negative, and notice how it's attached to the dock by a rope. We did this to show that cholera does not invade the mucosa. It simply uses fimbriae to attach to ganglioside receptors in the intestinal wall. After it does this, it secretes cholera toxin, which causes all of the symptoms of cholera. And of course, we're expected to know exactly how this toxin works. So let's look back at the map. Notice at the top it says base camp. You'll also notice actually that the C in camp is lowercase. This is because camp actually stands for CAMP or cyclic AMP. And this will remind you that the toxin increases cyclic AMP. But we still need to know a little more detail than just that. We also have to know how it increases CAMP. Cholera toxin binds to and constitutively activates adenylate cyclase, which is part of the GS pathway. To remember that it activates this GS pathway, we'll draw all of the soldiers carrying tear gas canisters. The G and the S in gas will remind us of GS, so we went ahead and wrote that on the canister. That should be good enough. So overall, just remember, cholera toxin activates GS, causing an increase in CAMP, which leads to secretion of water into the intestinal lumen, hence the watery diarrhea. So it should all make a lot of sense now. Alright, now that we know where all the watery diarrhea comes from, how do we treat cholera? Well, although antibiotics have been shown to reduce duration of symptoms, the primary treatment is still oral rehydration therapy with electrolytes. We'll represent this simply by having the colonel drinking water. Okay, now turn your attention back to the map. Notice it says base camp. Well, we call it base camp for a reason. We actually mean base as in alkali. And this is because cholera is said to grow in alkaline media. It prefers basic environments. With that said, you can imagine what it thinks about the environment of our stomach after we've ingested it. It hates it. It has a very tough time surviving in this acidic environment. So we have a term for this, a term that we've actually used before. Cholera is what we call acid labile. We'll use the same symbol we use to represent acid labile in salmonella. And we'll just have the colonel drinking his water with lemon slices. Finally, we'll add this blue ring to the kernel's finger. This ring is our symbol for oxidase positive. And that's all the high yield facts you'll need to know for Vibrio cholerae. But we do have two other lower yield bacteria in the Vibrio genus, Vibrio vulnificus and Vibrio parahemolyticus. All we think you should really know though about these two non-cholerae Vibrios is that they can contaminate seafood, especially oysters. So we'll draw some oysters on the plate to go with the kernel's lemon. And with that, we're done with Kernel Cholera's base camp. Hopefully the title alone gets you a couple questions right, because from the title, you know that cholera grows in alkaline media, and its toxin also causes that increase in CAMP. Now on to the next one.